Hello, in this lecture I answer two questions. In the first question, we find out the radius of this circle, and in the second question, we find out the area of this green shape using two different methods. So we start with the first question. In the drawing, we have quadrilateral ABCD that is inscribed by this circle. AB equals to AD equals to 4, CB equals to 6, DC equals to 8, and our task is to find out the radius of this circle. So first of all, we define this angle DCB as theta. Quadrilateral ABCD is inscribed by this circle, and therefore the sum of those two opposite angles must be equal to 180 degrees according to rule 70. So repeat quickly rule 70. According to rule 70, in any cyclic quadrilateral, the sum of the opposite angles must be equal to 180 degrees. So in the drawing we have quadrilateral ABCD that is inscribed by this circle. Therefore, because of the fact that quadrilateral ABCD is a cyclic quadrilateral, the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. That is to say, gamma plus delta also must be equal to 180 degrees. Alpha plus beta must be equal to 180 degrees, and gamma plus delta must be also equal to 180 degrees according to this rule 70. So we can actually implement rule 70 in our drawing. According to rule 70, the sum of those two opposite angles must be equal to 180 degrees. But this angle equals to theta, therefore this base angle must be equal to 180 degrees minus theta. Why? Because of the fact that 180 degrees minus theta plus theta equals to 180 degrees, that is the sum of those two opposite angles, according to 170. So in the next step, we'll join points B and D together by a straight line. By joining points B and D, we divided quadrilateral ABCD into two triangles. We have the upper green triangle ABD. The second part is actually triangle BCD. So in the next step, we will implement the law of cosines on those both triangles. So repeat quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. AB equals to unity in itself, AC equals to B unity in itself, this BC equals to C unity in itself, this is angle BAC that is equal to theta degrees in size. So this triangle ABC that could be any triangle, according to the law of cosines, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can implement the law of cosines in this triangle, green triangle ABD. According to the law of cosines, in the green triangle ABD, the following equation is true. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. So now, according to the law of cosines, this great triangle ABD, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. But again, according to the law of cosines, in this triangle ABD, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we substitute cosine 180 degrees minus theta in this equation 1 by minus cosine theta. And you get that BD squared equals to AB squared. AB is 4, therefore AB squared is 4 squared, that is 16. Plus AD squared. AD is also 4, therefore AD squared is 4 squared, that is 16. Minus 2 times AB, that is 4, times AD, that is also 4, times cosine 180 degrees minus theta. Cosine 180 degrees minus theta equals to minus cosine theta. So here we have minus times minus is plus. So this expression is a positive expression. So according to equation 1, if you found out that BD squared equals to 16 plus 16 is 32. Again, this expression is a positive expression, so it is plus 2 times 4 is 8, 8 times 4 is 32. So in total this expression equals to plus 32 cosine theta. So according to equation 1, if you found out that BD squared equals to 32 plus 32 times cosine theta. This is according to equation 1. In the next step, we will implement the law of cosines in this white triangle, triangle BDC. So according to the law of cosines, in this triangle BDC, the following equation is true. BD squared equals to BC squared plus CD squared minus 2 times BC times CD times cosine theta. So in the norm, this is my triangle BDC. According to the law of cosines, the following equation is true. BD squared equals to BC squared plus CD squared minus 2 times BC times CD times cosine theta. And again, according to the law of constants, this triangle BDC, the following equation is true. BD squared equals to BC squared plus CD squared minus 2 times BC times CD times cosine theta. So BD squared equals to BC squared. BC is 6, therefore BC squared is 6 squared, that is 36, plus DC squared. DC is 8, therefore DC squared is 8 squared, that is 64, minus 2 times BC is 6, times CD is 8, times cosine theta. So in total, according to equation 2, we should find out that BD squared equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So BD squared equals to 36 plus 64. 36 plus 64 is 100, minus 2 times 6 is minus 12, minus 12 times 8 is minus 96. So in total, this expression equals to minus 96 times cosine theta. So according to equation 2, if we found out that BD squared equals to 100 minus 96 cosine theta. This is according to equation 2, and according to equation 1, we only found out that BD squared equals to 32 plus 32 times cosine theta. So we have two different equations for BD squared. Therefore, we get equation 3 that states that BD squared according to equation 1 must be equal to BD squared according to equation 2. Very simple equation. So BD squared according to equation 1 equals to 32 plus 32 times cosine theta. And it must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to 100 minus 96 times cosine theta. Here we'll subtract 32 from this equation, equation 3. And you get that here 32 will get cancelled. After we cancel 32, in this side of the equation, we left only with 32 times cosine theta equals to 100 minus 32 is 68 minus 96 times cosine theta. So here we add to this equation, equation 3, 96 cosine theta. So here, minus 96 cosine theta will get cancelled. So in this side of the equation 3, we have to leave 68. While on the other side of the equation 3, we have 32 cosine theta plus 96 cosine theta equals to 128 cosine theta. So according to equation 3, we found out that 188 cosine theta equals to 68. Here we divide this equation 3 by 2 by 128. Again, according to this equation 3, cosine theta equals to 68 over 128. So here we divide both sides of this number by 2. 68 over 2 is 34, over 128 over 2 is 64. we divide both the numerator and the denominator of this number by 2. 32 over 34 over 2 is 17, and 64 over 8 is 32. So those two sides of the equation are equal to each other. And again, those two sides of the equation are equal to each other. That is to say, cosine theta equals to 17 over 32. According to equation 3, we have found that cosine theta equals to 17 over 32. We have the trigonometric identity that says that sinus squared theta plus cosine squared theta equals to 1. It is very easy to prove this trigonometric identity, but we will not do it in this lecture. So here we subtract cosine squared theta from this equation, and we get that sinus squared theta equals to 1 minus cosine squared theta. So here we take a root out of this equation, and here you get that sinus theta, the square root of sinus squared theta is of course sinus theta, equals to the square root of 1 minus cosine squared theta. But again, we should found out that sinus theta equals to the square root of 1 minus cosine squared theta. We already found out that cosine theta equals to 17 over 32. So here we'll square this equation, and we'll get that cosine squared theta equals to 17 over 32 squared. 17 over 32 squared is equal to 0.2822. Again, 17 over 32 squared equals to 0.2822. So those two sides of the equation are equal to each other. That is to say, cosine squared theta equals to 0.822. Cosine squared theta, in total it is equals to 0.2822. So now we can substitute cosine squared theta in this equation, in this trigonometric identity, by 0.2822. We do it now, we get that sinus theta equals to the square root of 1 minus cosine squared theta. Cosine squared theta equals to 0.2822. So I should found out that sinus theta equals to the square root of 1 minus 0.22. 1 minus 0.22 is equal to 0.717. So in total we should found out that sinus theta equals to the square root of 0.717. That is to say, in total sinus theta is equal to 0.847. And again, in total, if you found out that sinus theta equals to 0.847. What is the length of BD? We use Question 1 that said that BD squared equals to 32 plus 32 times cosine theta. So according to equation 1, BD squared equals to 32 plus 32 times cosine theta. And again, if you found out that BD squared equals to 32 plus 32 times cosine theta. But we already found out that cosine theta equals to 17 over 32. So we can substitute here cosine theta by 17 over 32. We'll do it now and get that BD squared equals to 32 plus 32 times cosine theta. And cosine theta is 17 over 32. So here we have 32 in the numerator, 32 in the denominator, so 32 will get cancelled. Here we left only with 17. So in total, if we found out the BD squared equals to 32 plus 17, that is 49. So here we take out down to this equation, if I get that BD equals to the square root of 49, that is 7. So BD equals to 7 units in Israel. BD equals to 7 units in Israel. So in total, if you found out that BD equals to 7 units in Israel, and sinus theta equals to 0.847. So in the next step, we'll implement the law of sines on this triangle BCD. So I'll paint quickly on the law of sines. In the drawing we have triangle ABC that is described by this circle. AB equals to C, AC equals to B, BC equals to A. This is angle BAC, that is equals to capital A divided in size. This is angle ACB, that is equals to capital C divided in size. And finally, this is angle beta. This is angle ABC, that is defined as capital beta, degrees in size. So, the law of sines in its full version, that is to say, the law of sines that is described by this circle, we have a special formula for the law of sines when this triangle ABC is described by this circle. It is called the full version of the law of sines. If you don't have a circle at all, then it is a partial law of the law of sines. We implement the partial law of the law of sines if we don't have a circle that is described triangle ABC. So in this triangle ABC, according to the full version, we implement the law of sines on this one triangle BDC in its full version. So repeat again, that according to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. And again, according to the law of sines, now drawing the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we'll implement the law of sines on this right triangle BDC in its full version. We can implement the law of sines in its full version because of the fact that triangle BDC is inscribed by this circle. The right triangle BDC is inscribed by this circle because of the fact that all the three vertices of this triangle BCD are located on the circle itself. B, C, and D. Therefore, we can implement the law of sines in its full version on this right triangle BDC. According to the law of sines, this right triangle BDC, the following equation is to BD over sin of theta equals to 2r. Again, BD over sin of theta equals to 2r. And R is the radius of this circle that blocks the triangle ABC. And also R is the radius that we are looking for this question. So, in triangle ABD, the right triangle ABD, according to the law of sines, the following equation is to BD over sin of theta equals to 2r. And BD over sin of theta equals to 2r. And R is the radius of this circle that blocks side BCD. And it is also the radius that we are looking for this question. BD 7 over sin of theta is 0.847, and it is equal to 2r. So 7 over 0.847 equals to 2r. So what is the value of 7 over 0.847? It actually equals to 8.2644. So 8.2644 equals to 2r. Here we divide this equation by 2 and find out that the radius R, that is the radius that we are looking for this question, equals to 8.2644 over 2. It's actually 4.132 units in itself. And again, in total, we should find out that the radius of this circle, the radius R equals to the radius R of this circle equals to 4.132 units in itself. So, we finish with the first question. So in the next step, I'll present to you the second question of this lecture. We answer the second question. In the second question, our task is to find out the area of this green shape. So in the drawing, we have the big right triangle ABC. This is angle ACB, that equals to 2 theta degrees in size. AP equals to 5, PB equals to 4. Again, our task is to find out the area of this green shape. So we start with the first method. So first of all, we will complete the missing angle on those both triangles and the big triangle ABC. This is the big right triangle ABC. In the big right triangle ABC, this angle equals to 90 degrees. This angle equals to 2 theta, therefore this missing angle must be equal to 90 degrees minus 2 theta. Why could 90 degrees minus 2 theta plus 2 theta equals to 90 degrees. 90 degrees plus 90 degrees equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, on this right triangle PBC, this angle equals to 90 degrees, this angle equals to theta, therefore this first angle must be equal to 90 degrees minus theta, according to the sum that we mentioned that the sum of the angles in any triangle is equal to 180 degrees. Therefore this first angle must be equal to 90 degrees minus theta. So in the next step, we will do a construction, that is to say, from this point P, we will do perpendicular on AC. Again, from point P, we will do perpendicular on side AC of this triangle ABC. So finally, this angle equals to 90 degrees inside, this angle also equals to 90 degrees inside, for construction. We define the touching point of the perpendicular from point P and AC. This point is point Q. By doing this construction, we created the right triangle PQC. This right triangle PQC, this angle equals to theta, this angle equals to 90 degrees, therefore this first angle must be equal to 90 degrees minus theta. According to the symbol, this says that the sum of the angles in any triangle is equal to 180 degrees. So, in the next step, we prove that those two right angles can go into each other according to angle side angle rule. So, we have to prove that this is the green right triangle PQC. The green right triangle QPC can go into this right triangle PBC. So why those two triangles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is again QPC. And again, this is again QPC. And it is equal to this angle, this is actually again BPC. So again, in total, we found out that angle QPC in the right triangle is equal to angle BDC in the right triangle. Again, BPC is P. So again, QPC in the right triangle equals to again BPC in the right triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side PC, this is a common side that belongs to both triangles, so we can write down that PC equals to itself is a common side that belongs to both triangles. And finally, those two angles they are both equal to theta, and therefore they are equal to each other. So here, this is angle ACP, the green triangle, and it is equal to this angle PCB in the white triangle. So in total, we found out that those two right triangles can go into each other according to angle side angle rules. So we found out in total that the green right triangle PQC congruent. This is the sign of congruent to the right angle PBC. According to angle side angle rule. Again, if you follow in total, those two angles congruent to each other according to angle side angle rule. What is angle side angle rule? If you prove that those two angles and the side that is included between those two angles in this current angle correspond equal to those two angles, and the side that is included between those two angles this right angle. Therefore, those two right angles congruent to each other according to angle side angle rule. We have those two angles and the side that is included between those two angles in the rectangle correspond equal to those two angles, and the side that is included between those two angles this right angle. Therefore, those two right angles congruent to each other according to angle side angle rule. And from the fact that those two right angles congruent to each other, we will derive that their corresponding sides must also equal to each other and their lengths. This is to say PQ equals to PB. So PQ equals to PC, PQ equals to PB, PB is 4, so can I down here that PB is 4, and from the equation PB equals to PQ equals to PB equals to 4, we derive that PQ also equals to 4 units in itself. This is the units inside PQ that equals to 4 units in itself. From the drawing, it is very easy to see that the big rectangle ABC is similar to this white small rectangle APQ. So why the big triangle ABC is similar to this small rectangle APQ? First of all, this is angle A. Angle A is a common angle that belongs to both angles. Therefore, can write down that angle A equals to itself is a common angle that belongs to both angles. In addition, those two angles are both equal to 90 degrees and therefore are equal to each other. Likewise, those two angles are both equal to 90 degrees and theta and therefore are equal to each other. And finally, those two angles are both equal to theta and therefore they are equal to each other. So, in total, we found out that all the figures of the big rectangle ABC are corresponding equal to all the figures of this small rectangle APQ. Therefore, those two rectangles are similar to each other according to angle similarity. So, at the now, we found out in total that the big rectangle ABC is similar. This is the sign of similar of this white rectangle APQ. The big triangle ABC similar to this very small triangle APQ according to angle similarity rule. And from the fact that the big rectangle ABC is similar to this small rectangle APQ, we derive that the following relationship exists between their sides. We derive the side AP of this rectangle APQ over side, we derive the side AP of this green small triangle APQ over side we derive the side AP of this green small triangle APQ over side we derive the side AP of this green small triangle APQ or side AC of this big rectangle ABC is equal to side PB of this green small triangle APQ PQ over side AB. Because again, from the fact that this is the small rectangle APQ similar to the big rectangle ABC, we know that the following relationship exists between their sides. We know that side AP of the small green triangle over side AC of the big triangle equals to side PQ of the small triangle over side AB of the big triangle. AP is 5 over AC. We define AC as A and BC as B. So here AC equals to B, AC equals to A according to our definition. Again, AC equals to A according to our definition, and it is equals to PQ. PQ is 4 over BC. BC is B. So if you found out that 5 over A equals to 4 over B. So here we first multiply this equation. It's actually BC. So here we first multiply this equation. And finally get that 5B equals to 4A. 5B equals to 4A. So if we define A is 5x, what is the value of B? We just have to substitute A by 5x in this equation, and this way we find out the value of B. So 5B equals to 4A, and A is 5x. So in total, we found out that 5B equals to 4 times 5x. So we have 5 on both sides, so 5 will get cancelled, and we're left only with B equals to 4x. So in total, if we found out that if A equals to 5x, then B must be equal to 4x. And again, if we found out that if A equals to 5x, then b must be equal to 4x. In the next step, we will implement the product theorem on this big right triangle ABC. Here by PT is the brochure for product theorem. According to the product theorem, in a right triangle, the score of the hypotenuse equals to the sum of the scores of the perpendiculars. So this big right triangle ABC, AC squared, that is the score of the hypotenuse, must be equal to AB squared plus BC squared. And again, according to the product theorem, in this big right triangle ABC, AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC equals to 5x, or AC equals to A equals to 5x, so AC equals to 5x, therefore AC squared equals to 5x squared. 5x squared is 25x squared. So AC squared equals to 25x squared, and is equals to AB squared. AB in total equals to 5 plus 4, that is 9, therefore AB squared equals to 9 squared, that is 81. So AB squared equals to 81 plus BC squared. BC equals to B, and B equals to 4x. BC equals to 4x, therefore BC squared equals to 4x squared. 4x squared is 16x squared. So in total, we found out that 25x squared equals to 81 plus 16x squared. Here we subtract 16x squared from this equation. So here 16x squared gets cancelled. On the other side of the equation, we have 25x squared minus 16x squared is 9x squared equals to 81. So we divide this equation by 9. I get that 9x squared over 9 is x squared equals to 81 over 9. 81 over 9 is 9. So in total, we found out that x squared equals to 9. Here we take out of the equation and find again that x equals to the square root of 9, that is 3. So x equals to 3 is in its length. AC equals to 5x, x equals to 3. 5x is 5 times 3, that is 15. So in total, we found out that AC equals to 15 units in its length. Likewise, BC equals to B and B equals to 4x. 4x is 4 times 3, that is 12. So in total, BC equals to 12 units in its length. Our test is to find out the area of this green shape. So what is the area of the green shape? What is the green shape? The green shape is the green triangle APC. So our task is actually to find out the area of this green triangle APC. And again, we should find out that our task is to find out the area of the green shape. That's actually the area of the green triangle ABC. What is the area of the green triangle ABC? We know that the area of green triangle equals to the base of the triangle times the height of the base over 2. So we choose the base of this green triangle APC as AC. The height to the base must get 90 degrees with the base. So the height to the base AC is PQ. Why? Because of the fact that PQ gets 90 degrees with the base AC. Those two angles are both right angles. So the base is PQ over 2. In total, we found out that the area of the green shape equals to the base AC, that is 15, times PQ, that is 4, divided by 2. So we found out that the green shape equals to 15 times 4 is 60, 60 over 2 is 30. So today we found out that according to the first method of this question, we have the green shape is equal to 30 squares in size. And again, if you found out that according to the first method, we have this green shape equals to 30 squares in size. So we finish with the first method. In the next step, I will present to you how to find out they have this green shape according to the second method. In the second method, we focus on this white triangle PBC. On this white triangle PBC, it is very easy to see that those figures are above theta, of course. In this white triangle PBC, it is very easy to see that tangle theta equals to PB over BC. So the white lower triangle PBC it is very easy to see that tangents theta equals to PB over BC. We define the length of BC as B. So tangent theta equals to PB. PB is 4 over BC. BC is B according to our definition. So in total, if you found out that according to equation 1, tangent theta equals to 4 over B. In this big triangle ABC, the big triangle ABC, it is very easy to see that tangents 2 theta equals to AB over BC. Again, tangents 2 theta, this big right triangle ABC equals to AB over BC. AB equals to 5 plus 4, that is 9. Or BC. BC equals to B according to our definition. So in total, according to equation 2, we found out that tangents 2 theta equals to 9 over B. This is according to equation 2. According to equation 1, we already found out that tangent theta equals to 4 over b. We have the trigonometric identity that states that tangent to theta equals to 2 times tangent theta over 1 minus tangent squared theta. This is equation 3, is the trigonometric identity. Here, TA is relation for trigonometric identity. So here, we substitute tangent to theta, this trigonometric identity, by 9 over b. And it equals to 2 times tangent theta. So it is 2 times tangent theta. Tangent theta is 4 over b. So substitute tangent theta by 4 over b over 1 minus tangent squared theta. Tangent theta equals to 4 over b, therefore tangent squared theta must be equal to 4 over b squared. 4 over b squared equals to 16 over b squared. So in total, we should find out that according to equation 3, 9 over b equals to 2 times 4 over b. 2 times 4 is 8, so this expression equals to 8 over b divided by 1 minus 16 over b squared. So write it down again. According to equation 3, we found out that nine over b equals to 8 over b divided by 1 minus 16 over b squared. And again, according to equation 3, we found out that 9 over b equals to 8 over b divided by 1 minus 16 over b squared. So here we multiply this equation 3 by 1 minus 16 over b squared. So this expression gets cancelled. And in this side of the equation 3 we have 9 over b times 1 minus 16 over b squared equals to 8 over b. This expression has been cancelled, so we have only with 8 over b this side of this equation. So in total, we found out that 9 over b times 1 minus 16 over b squared equals to 8 over b. So here we have b on both sides of this equation, so b will get cancelled. After we cancel b, this side of the equation we left only with 9 times 1 minus 16 over b squared. While on the other side of this equation we left only with 8. So in total we found out that 9 times 1 minus 16 over b squared equals to 8. Here we'll open the brackets of this on this side of this equation, equation 3. We get that according to equation 3, nine times 1 is 9. Here we have 9 times minus 16 is minus 144 divided by b squared. Equals to 8. Here we subtract 8 from this equation, equation 3. Nine minus 8 is 1. So here we have also minus 144 over b squared equals to 8 minus 8 is 0. So here we let 144 over b squared to this equation 3. Very good, is according to this equation 3. Here, minus 144 over b squared will get cancelled. So here we're left only with 1 equals to 0 plus 144 over b squared equals to 144 over b squared. So if you found out that according to equation 3, 1 equals to 144 over b squared. Here we will multiply this equation 3 by b squared. According to equation 3, we have 1 times b squared is b squared. Here b squared gets cancelled, we left only with 144. So in total, if you found out that b squared equals to 144, you will take out all those equations, finding that b equals to the square root of 144, that is 12. So b equals to 12 units in Israel. B equals to 12 units in Israel. Our task is to find out the area of this green shape. So what is the area of the green shape? The green shape is actually the green triangle APC. So our task is to find out the area of this green triangle APC. What is the area of the green triangle ABC? Actually, you know that the area of any triangle equals to the base of the triangle times the height of the base over 2. We choose the base of this green triangle APC as AP. The height of the base must rate 90 degrees with the extended base. AP is the base, the extended base is AB. So the height of the base must rate 80 degrees with AB. CB definitely gets 90 degrees with AB because of the fact that this is a right angle. Therefore, the height of the base is CB because it gets 90 degrees with the extended base. So the height of the base is CB over 2. AP is 5 times CB. CB is 12 over 2. So in total, if you found out that the area of the green shape according to the second method equals to 5 times 12 is 60. 60 over 2 is 30. The area of the green shape according to the second method equals to 30 square units in size. So actually, in both methods, if you found out that the area of this green shape, that is the area that we are looking for this question, is equal to 30 square units in size. So finish to answer the second question. The next step, answer the next step, that is to say, we repeat on the solution of the first question, and then we repeat on the solution of the second question on both methods. In the first question, our test is to find out the radius of this circle. So in the drawing, we have quadrilateral ABCD that is described by this circle. AB equals to AD equals to 4, BC equals to 6, CD equals to 8. Again, our task is to find out the radius of this circle. So first of all, we define this angle BCD is theta. Therefore, this piece angle must be equal to 180 degrees minus theta according to rule 70. So repeat quickly on rule 70. According to rule 70, in any cyclic quadrilateral, the sum of the opposite angles must be equal to 180 degrees. Quadrilateral ABCD is inscribed by this angle, therefore it is a cyclic quadrilateral. So the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. That is to say, lambda plus delta equals to 180 degrees. So can you implement rule 70 in our drawing? When I put in our drawing, somebody mentioned before, quadrilateral ABCD is inscribed by this angle. Therefore, the sum of those two opposite angles, the sum of those two opposite angles must be equal to 180 degrees according to rule 70. This angle theta, therefore this piece angle must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of those two opposite angles. Therefore, this piece angle must be equal to 180 degrees minus theta. The next step, implemented the law of cosines on both triangles. Actually, we join points B and D together by a side line. Once we join points B and D, we divided quadrilateral ABCD into two parts. This is the first part, that is the ring triangle ABD. This is the second part, that is white triangle PDC. So in the next step, we implemented the law of cosines on both those triangles. So first of all, we implemented the law of cosines. The law of cosines of this ring triangle ABD. So I can click on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. Side AB equals to unit in itself, side AC equals to B unit in itself, side BC equals to C unit in itself. This is angle BAC that is equals to theta degrees in size. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can actually implement the law of cosines on this ring triangle ABD. According to the law of cosines, in this ring triangle ABD, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. Repeat again, this ring triangle ABD, according to the law of cosines, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. So we can substitute cosine 180 degrees minus theta by minus cosine theta. Yeah, we did it here. We substitute cosine 180 degrees minus theta here by minus cosine theta. So in total, we found out that BD squared equals to AB squared. AB is 4, therefore B squared is 4 squared, that is 16, plus AD squared. AD is also 4, therefore AD squared is 4 squared, that is 16. Minus 2 times AB, that is 4, times AD, that is also 4, times cosine 180 degrees minus theta. Again, in total, we found out that according to equation 1, BD squared equals to 16 plus 16, minus 2 times 4 times 4 times cosine 180 degrees minus theta equals to minus cosine theta. So it is minus 2 times 4 times 4 times minus cosine theta. Minus times minus is plus. So this expression in total it is a positive expression. So in total we found out that BD squared equals to 16 plus 16 is 32. This is a positive expression. So it is plus 2 times 4 is 8. 8 times 4 is 32. So in total this expression equals to 32 cosine theta. Plus 32 cosine theta. So in total according according to equation 1, we found out that BD squared equals to 32 plus 32 times cosine theta. In the next step, implement the law of cosines on this right triangle BCD. According to the law of cosines, this right triangle BCD, BD squared equals to BC squared plus CD squared minus 2 times BC times CD times cosine theta. And again, this right triangle BDC, according to the law of cosines, the following equation is true. BD squared equals to BC squared plus CD squared minus 2 times B minus 2 times BC times CD times cosine theta. So BD squared equals to BC squared. BC is 6, therefore BC squared is 6 squared, that is 36. Plus DC squared. DC is 8, therefore DC squared is 8 squared, that is 64. Minus 2 times BC, that is 6, times CD, that is 8, times cosine theta. So total, we should find out that BD squared equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So BD squared equals to 36 plus 64 is 100. Here we have minus 2 times 6 is minus 12. Minus 12 times 8 is minus 26 times cosine theta. So in total, according to equation 2, we should find out that BD squared equals to 100 minus 96 cosine theta. This is equation according to equation 2. And according to equation 1, we already found out that BD squared equals to 32 plus 32 times cosine theta. So we have two different equations for BD. We have two different equations for BD squared. Therefore, we get the equation 3 that states that BD squared according to equation 1 must be equal to BD squared according to equation 2. Very simple equation. So BD squared according to equation 1 equals to 32 plus 32 times cosine theta. It must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to 100 minus 96 times cosine theta. So in total, we found out that according to equation 3, 32 plus 32 times cosine theta equals to 100 minus 96 times cosine theta. Here subtracted 32 from this equation, so equation 3. So here 32 we get cancelled, the left only with 32 times cosine theta on this side of the equation. While on the other side of the equation, we have 100 minus 32, that is 68 minus 26 times cosine theta. So in total, if you found out according to equation 3, 32 times cosine theta equals to 68 minus 96 times cosine theta. Here we added 96 cosine theta to this equation 3, so here 96 cosine theta will get cancelled, the left only with 68 on that side of the equation, and on the other side of the equation we have 96 times cosine theta plus 32 cosine theta equals to 128 cosine theta. So in total, if you found out that according to equation 3, 196 cosine theta, 198 cosine theta, 128. 96 cosine theta plus 32 cosine theta equals to 128 cosine theta. So total according to equation 3, we found out that 128 cosine theta equals to 68. Here we divided this equation 3 by 128, and found out that cosine theta equals to 68 over 128. Here we divided both the numerator of this number by 2. 68 over 2 is 34, and 28 over 2 is 64. Likewise, we divided also this number by both the numerator of this number by 2. 34 over 4 is 34 over 2 is 17, and 64 over 2 is 32. So in total, if you found out that cosine theta equals to 17 over 32. Again, cosine theta equals to 17 over 32. What is the value of BD? But before that, we have the trigonometric identity that says that sin squared theta plus cosine squared theta equals to 1. So here we subtracted from this trigonometric identity cosine squared theta. If you found out that sin squared theta equals to 1 minus cosine squared theta. Here we took out of this equation, and we found out that sin theta equals to the square root of 1 minus cosine squared theta. We already found out that cosine theta equals to 17 over 32. So we squared this equation, and we found out that cosine squared theta must be equal to 17 over 32 squared. 17 over 32 squared equals to 0.2822. So in total, we found out that cosine squared theta equals to 0.2822. And cosine squared theta equals to 0.2822. We already found out that sin theta equals to the square root of 1 minus cosine squared theta, and therefore we substitute cosine squared theta in this equation by 0.2822. In total, we found out that sinus theta equals to the square root of 1 minus cosine squared theta is 0.2822. So in total, we found out that sinus theta equals to the square root of 1 minus 0.2822. 1 minus 0.2822 equals to 0.717. So in total, inside the root, we left only with 0.717. So sinus theta equals to the square root of 0.717. The square root of 0.717 is equal to 0.847. So in total we found out that sinus theta equals to 0.847. What is the value of BD? According to equation 1, BD squared equals to 32 plus 32 times cosine theta. So BD squared equals to 32 plus 32 times cosine theta. Cosine theta is 17 over 32. So we solve cosine theta here by 17 over 32. So in total we found out that BD squared equals to 32 plus 32 times 17 over 32. We have 32 in the denominator, 32 in the denominator, so 32 gets cancelled. Here we left only with 17. So in total we found out that dB squared equals to 32 plus 17 is 49. Here we took out all the equation and we found out that BD equals to the square root of 49, that is 7. BD equals to 7. And we only found out that sinus theta equals to 0.847. In the next step, we implemented the law of sines on this white tile DBC. So I print picture of the law of sines. The law of sines is true. The law of sines is true in any triangle. This is a triangle ABC that could be in a triangle. Actually, triangle ABC is inscribed by this circle. So you can implement the law of sines in its full version. We know that the radius of this circle is R. AB equals to C units in itself, AC equals to B units in itself, BC equals to A units in itself. This is again BAC, this is equal to capital A degrees in size. This is again ACB, this is equal to capital C degrees in size. And finally, this is again ABC, this is equal to capital B degrees in size. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now it's the radius of this circle that blocks triangle ABC. Again, the law of cosines is in its full version. It says that A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we implemented the law of sines on our triangle BCD in its full version. Why we can implement the law of sines in its full version? Because of the fact that triangle BCD is inscribed by this circle. That is to say, all the three vertices B, C, and D lie on this circle. Therefore, triangle BCD is inscribed by this circle. Therefore, we can implement the law of sines in triangle BCD in its full version. According to the law of sines in its full version, we get that BD or sinus theta equals to 2R. And now is the radius of this circle that blocks triangle ABC. So according to the law of sines, if we focus on the white triangle ABD, BCD, the following equation is to BD over sinus theta equals to 2R. And R is the radius of this circle, that is the radius that we are looking for this question. BD is 7, sinus theta is 0.847. So in total, we found out that 7 over 0.847 equals to 2R. 7 over 0.847 is equal to 8.2644 equals to 2R. 8.2644 equals to 2R. Here we divide this equation by 2 and we found out that R equals to 0.8, R equals to 8.2644 over 2, this is 4.132 units in itself. So that we actually found out that the radius of this circle, that is the radius that we are looking for this question, is equal to 4.13 units in its length. Okay. So we finished to repeat on the first question. The next step, I repeat on the solution of the second question of on both methods. In the second question, our task was to find out the area of this red shape. So in the drawing, we have the big right angle ABC. This angle ACB, this is equal to 2 theta degrees in size. AP equals to 5, PB equals to 4. Again, our task is to find out the area of this red shape. So first of all, we found the missing angles in this drawing. According to the rule that said that the sum of the angles in any triangle is equal to 180 degrees. So in the big right triangle ABC, this angle equals to 90 degrees, this angle equals to 2 theta, therefore this missing angle must be equal to 90 degrees minus 2 theta. Why? Because of the fact that 90 degrees minus 2 theta plus 2 theta equals to 90 degrees. 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. Therefore this missing angle must be equal to 90 degrees minus 2 theta. Likewise, in this this white triangle PBC, this angle equals to 90 degrees, this angle equals to theta, therefore this missing angle must be equal to 90 degrees minus theta according to the sum that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step we did a construction, that is to say, from point P we go perpendicular on AC. Again, from point P we go perpendicular on AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in AC, this point is point Q. By doing this construction, we rendered the right triangle PQC. In the green right triangle PQC, this angle equals to theta, this angle equals to 90 degrees, therefore this angle is equal to 90 degrees minus theta. 1 equals 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. So here, in the next step, we prove that those two adjacent triangles, that is to say the green upper triangle PQC and the white triangle PBC, can point to each other according to sine angle side rule. So write those two adjacent triangles can point to each other. First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, PC is a common side that belongs to both triangles, so we can write down that PC equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to theta, therefore they are equal to each other. So in total, we found out that the green triangle PQC is converted to the white triangle PBC according to sine angle side rule. And again, in total, we found out that the green triangle PQC convert, this is the same convert to the white triangle PBC according to angle side angle rule. What is angle side angle rule? We actually found out that those two angles and the side that is included between those two angles is actually side PC. This red triangle corresponding equal to those two angles and the side that is included between those two angles, that is also side PC, this white triangle. And therefore those two right triangles can point to each other according to sine angle side rule. We have those two sides and those two angles and the side that is included between those two angles in the green triangle corresponding equal to those two angles and the side that is included between those two angles in the white triangle. And therefore those two right triangles can point to each other according to sine angle side rule. And from the fact that those two right triangles can point to each other, we know that PB equals to PQ. PB equals to PQ according to the rule that corresponding sides and right triangles are equal to each other. Those two triangles can point to each other, and therefore their corresponding sides, that is to say PQ and PB, must be also equal to each other in their lengths. But PB is 4, so we can write here that PB is 4. PB is 4, and from this equation PQ equals to PB equals to 4, we'll have that PQ must be also equal to 4 units inside. This is the missing side PQ, it's also equals to 4 units inside. The next step we proved is actually very easy to see from the problem itself that the big triangle ABC is similar to this small green triangle APQ. That is to say, this is angle 8, it is a common angle that belongs to both triangles, so we can write down that angle 8 equals to itself is a common angle that belongs to both triangles. In addition, we have those triangles that are both equal to 90 degrees and therefore they are equal to each other. And finally, those triangles are both equal to theta, therefore they are equal to each other. Why this angle equals to theta, this angle equals to theta according to rule 3. Rule 3 says that the sum of the angles on one side of the third line is equal to 180 degrees. So the sum of the angles of this side of the third line AB at point P must be equal to 180 degrees according to rule 3. That is to say, y plus 90 degrees minus theta plus 90 degrees minus theta must be equal to 180 degrees. So y plus 2 times 90 degrees minus theta equals to 180 degrees. By solving the equation, we get that the missing angle PQ equals to 2 theta. Okay? So, in the big triangle ABC, similar to this small great triangle PQ, we're going to angle similar to. That is to say, this angle 8 is a common angle that belongs to both triangles, so we can write down that angle 8 equals to itself is a common angle that belongs to both triangles. In addition, those triangles are both equal to 90 degrees and therefore they are equal to each other. And finally, those triangles are both equal to theta and therefore they are equal to each other. So in total, we found out that all the figures of this big right triangle ABC correspond equal to all the figures of this small right triangle APQ. Therefore, those two right triangles are similar to each other according to angle and similar to all. And again, in total, we found out that the big right triangle ABC is similar, this is the sign of similar, to the green right triangle APQ according to angle similar to all. And from the fact that those two right triangles are similar to each other, we will have that the following relationship exists between their sides. We have the side AP of the green triangle APQ over side AC of the big triangle ABC is equal to side PQ of the green triangle PQA over side BC of this big triangle ABC. Okay, again, we have that AP over AC equals to PQ over BC. We defined AP, AC as A, the opposite AC as A, and BC as B. So here AP equals to 5 over AC. AC equals to A according to our definition, and it equals to PQ. PQ equals to 4 over BC. BC equals to B according to our definition. So in total, we should found out that 5 over A equals to 4 over B. If we multiply this equation, we found out that 5B equals to 4A. What is the meaning of this equation that 5B equals to 4A? It means that if we define A as 5x, then B must be equal to 4x. Why? Because of the fact that if if A equals to 5x, it means that we substitute A by 5x. And you get that 5B equals to 4A. A is 5x, so we substitute A by 5x. In total, we should found out that 5B equals to 4 times 5x. We have 5 on both sides of the equation, so 5 will be cancelled. And we have to leave with b equals to 4x. So in total, we should find out that if a equals to 5x, then b must be equal to 4x. Alright? If a equals to 5x, then b must be equal to 4x. The next step, implemented the product theorem on this big diagram ABC. According to the product theorem, AB squared equals to AC squared equals to AB squared plus BC squared. And again, according to the product theorem, this big right triangle ABC, AC squared equals to AB squared plus BC squared. AC is 5x, therefore AC squared is 5x squared. 5x squared is 25x squared. And it equals to AB squared. AB in total is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81, plus BC squared. BC is 4x, therefore BC squared is 4x squared. 4x squared is 16x squared. So in total, I should find out that 25x squared equals to 81 plus 16x squared. Here subtract 16x squared from this equation. If I found out that 25x squared minus 16x squared is 9x squared, equals to 81. 9x squared equals to 81. Here we divided this equation by 9. 9x squared over 9 is x squared. 81 over 9 is 9. So in total, we found out that x squared equals to 9. Here we took out of this equation. We found out that x equals to the square root of 9, that is 3. So x equals to 3, it's in its length. Again, our test is to find out the area of this green shape. So what is the area of the green shape? The green shape is actually the green triangle in PC. So our test is to find out the area of the green triangle in PC. The area of the triangle equals to the base of the triangle times the height of the base over 2. We choose the base of this green triangle in PC is AC. The base is AC, therefore the height to the base is PQ. One part of the cloud that PQ gets with the base AC. So the height and the base is AC according to our choice, and therefore the height is PQ because the greatest height is with AC divided by 2. So in total, we actually found out that the green shape equals to the base AC times the height PQ over 2. AC equals to 15, PQ equals to 4 divided by 2. Again, AC equals to 15, PQ equals to 4 divided by 2. 15 times 4 is 16, 16 over 2 is 30. So in total, according to the first method, this green shape equals to 30 square units in size. In the next step, I actually presented to you how to find out the area of this green shape according to the second method. This one triangle PBC times theta, this one triangle PBC times theta equals to PB over BC. Again, in the white triangle PBC, it is very easy to say that triangle theta equals to PB over BC. PB is 4, we define BC as B. PB is 4 and BC is B according to our definition. So in total, according to equation 1, we found out that triangle theta equals to B over 4. Next up, we focus on this big right triangle ABC. This big right triangle ABC tangles 2 theta equals to AB over BC. The big right triangle ABC tangles 2 theta equals to AB over BC. AB in total equals to 5 plus 4, that is 9 over BC. BC is B. And again, AB is 9, BC is B. So in total, if you found out that according to equation 2, times 2 theta equals to 9 over B. And times 2 theta equals to 9 over B. This is according to equation 2, while according to equation 1, we only found out that times theta equals to 4 over B. We have the trigonometric identity that says that times 2 theta equals to 2 times theta over 1 minus times square theta. We substitute the times 2 theta in this trigonometric identity by 9 over 4. And we substitute times theta in this trigonometric identity by 4 over B. So in total, if you found out that times 2 theta is 9 over B equals to 2 times times theta. Times theta is 4 over B over 1 minus times square theta. tangent theta is 4 over b, therefore tangent square theta must be equal to 4 over b squared. 4 over b squared equals to 4 squared, that is 16 over b squared. So in total, tangent square theta equals to 16 over b squared. So according to equation 3, we found out that 9 over b equals to 2 times 4 over b over 1 minus 16 over b squared. 2 times 4 is 8, so this expression equals to 8 over b over 1 minus 16 over b squared. The next step, so in total we found out that according to equation 3, 9 over b equals to 8 over b over 1 minus 16 over b squared. And again, according to equation 3, in total we found out that 9 over b equals to 8 over b over 1 minus 16 over b squared. Here we multiply this equation 3 by 1 minus 16 over b squared. So here 1 minus 16 over b squared will get cancelled. So in this side of the equation we left only with 8 over b. While on the other side of the equation we have 9 over b times 1 minus 16 over b squared. So total according to equation 3, we should find out that 9 over b times 1 minus 16 over b squared equals to 8 over b. We have b on both sides of this equation, so b will get cancelled. After cancelled b, in this side of equation 3 we left only 9 times 1 minus 16 over b squared equals to 8. So 9 times 1 minus 16 over b squared equals to 8. Here we open the brackets on this side of this equation 3, and we found out that 9 times 1 is 9. And we have in 9 times 1 is 16 minus 144 over b squared equals to 8. So in total according to equation 3, we found out that 9 minus 144 over b squared equals to 8. Here we subtracted 8 from this equation, so in total we found out that 9 minus 8 is 1 minus 144 over b squared equals to 8 minus 8 is 0. So in total we found out that according to equation 3, 1 minus 144 over b squared equals to 0. So here we have 144 over b squared to this equation, so here 144 minus 144 over b squared gets cancelled. While on the other side of the equation, 0 plus 144 over b squared equals to 144 over b squared. So in total we should find out that according to equation 3, 1 equals to 144 over b squared. Here we multiply this equation 3 by b squared, and finally found out that b squared equals to 144. Here we took out of this equation 3, and finally found out that b equals to the square root of 144. The square root of 144 is 12. In total we should find out that b equals to 12 means inside. BC equals to B equals to 12, so BC equals to 12. Our test is to find out they have this green shape. What is the green shape? The green shape that fills the green, triangle APC. So here our test is to find out they have the green triangle ABC. They have the green triangle APC. They have the green triangle APC. Actually you know that they have green triangle equals to the base of the triangle times the height to the base over 2. We choose the base SAP. The height to the base must get 90 degrees with the extended base. So the extended AP is AB. So the height to the base must get 90 degrees with AB. CB definitely gets 90 degrees with AB because of the fact that this is the right angle. So the height to the base is CB. And again, we choose the base SAP. The height to the base must be equal to CB over 2. AP is 5, CB is 14, AP is 5, and CB is 12. Again, AP is 5, CB is 12 divided by 2. 5 times 12 is 60, and 60 over 2 is 30. So total, we found out that they have this green shape, according to the second method, is equal to 30 square units in size. So in both methods, we actually found out that they have this green shape, that is the area that we are looking for in this equation, is equal to 30 square units in size. Okay, thank you very much.